Video problem number 41, mole relationships and chemical reactions. So here we're utilizing this concept called stoichiometry. So if you want to look up more problems to do or more example videos, you're just looking up stoichiometry is all you're doing. Uh-oh. There we go. All right. So in this case, we're working on moles to moles, which is the only new concept. Everything else we've done. All right. I always like to use what I call a roadmap. So I always set these problems up the same way when it's a stoichiometry problem. Let's take a look at it. Determine the number of moles of iron 3 sulfide. So I'm looking for moles, so are in line with the moles underneath iron 3 sulfide, formed if 0.55 moles of iron. So underneath the iron, I'm going to write 0.55 moles. Reacts with excess sulfur. So the excess sulfur just says that I have more than enough sulfur. I don't need to worry about it. So what I'm going to do is I'm going to go from moles to moles. Just like that, okay? So I'm going to set this up, 0.55 moles of iron. Okay? And now, I want to get rid of iron, but not moles. I want to keep the word moles. I want to get rid of iron. So I'm going to put iron on bottom, right? Because then the irons will cancel out. I'm going to put iron 3 sulfide, which is what I'm looking for, on top. And then I just need to figure out the relationship between iron 3 sulfide and iron. As it turns out, for every one iron 3 sulfide, there are 2 irons. So in this case, I'm just going to take 0.55 and divide it by 2. So we get a value of, sorry, the wrong button, 0.275. So iron cancels out. So I get 0.275. Moles didn't cancel out, so I still have that word moles, and Fe2S3 did not cancel out. So there's going moles to moles. So that's my answer, 0.275. All right, let's look at another one. Determine the number of moles of carbon dioxide. So I'm looking for moles of carbon dioxide generated when an excess amount of propane, so plenty of propane, reacts with 2.49 moles of oxygen. So I've got 2.49 moles of oxygen. So I'm just going to go moles to moles, right? 2.49 moles of oxygen. And I'm going to try to look for carbon dioxide. I want to get rid of oxygen. I'm looking for carbon dioxide. Okay, so the relationship is there are 3 carbon dioxides for every 5 oxygen. So oxygen cancels out. So it's going to be 2.49 times 3 divided by 5. And I get a value of 1.494. Let's see. I want 3 sig figs, so 1.49 is going to be good. And moles doesn't cancel out. Carbon dioxide doesn't cancel out. So that's my answer. That's what would go there. Right? So there you go. There's moles to moles.